This is Joe narrating a PowerPoint in science. It's in the unit on science practices. It's lesson 2, using the scientific method, found on page 494 in the Kaplan book. On the GED test, you will be asked to write up an experiment to test a hypothesis that they will give you. These generally take about 10 minutes to do, and what I want to do is show you a structure for your writing. So here's an example. My wife thinks that Palm, which is an expensive Belgian beer, tastes better than Yingling, a local inexpensive beer. So design an experiment that would determine if she can really tell the difference. So one option is to have 2 cups of beer, 1 Palm, 1 Yingling, in the same glasses, the same temperature, the same degree of freshness, and have her taste one beer and then the other and decide which is better. You can do that once, which wouldn't be good data because it might just be a guess that she would guess which one is the Palm and which one is the Yingling. But if you do a series of 2s, say 20 times, and if she can guess the Palm beer most of the times, or pick a number 80% of the time, then she can tell the difference between them. But if she can only tell which is Palm 50% of the time, that's no better than guessing, and you would suspect that she can't tell the difference. So your experiment would be to set up a pair of cups of beer, 1 Palm, 1 Belgian. She tastes each one in a little sip, and then decides which one is the Palm, and you record the data. She doesn't know which is the Palm, but you do. And then do that, say, 20 times. So the 2 groups are, one is Palm, one is Yingling, and you repeat the experiment 20 times. The data that you collect is the percentage of the time that she is correct, and your hypothesis would be true that she can't tell the difference if her degree of her percentage of time telling the Palm from the Yingling is roughly around 50%. So here's a summary of designing an experiment. First, determine what the hypothesis is. And the hypothesis is a testable prediction, meaning it's a prediction that you can test by doing an experiment. Then set up different groups. Usually there'll be 2 groups. And try to make only one difference between the 2 groups. In our beer experiment, we had the unknown beers in the cups, but all other factors were the same. Temperature, degree of freshness, color of the cup, and that's what those are called control variables, meaning things that could be different between the 2 groups, but we keep the same. So the only difference between the 2 groups is one is one type of beer, the other is the other type of beer. And then we collect data. Our data in the beer experiment was the percentage of time that she guessed the Palm. And we tell if our hypothesis is correct. That's usually straightforward. Our hypothesis is correct if the percentage of time guessing the Palm is around 50%. So here's some science vocabulary. The independent variable is the one difference between the 2 groups. In our case, it was one beer versus the other. The dependent variable is what you're going to measure. We are going to measure the percentage of time that she guesses the Palm after 20 pairings. The control variables are all the potential things that could affect your measurement and could be different between the 2 groups that we keep the same in the 2 groups. Things like temperature and freshness.